Example 1. Draw a direction field for the logistic equation with K equals 0.08 and the carrying capacity big M equals 1000. What can you deduce about the solutions? Solution: in this case, the logistic differential equation is d big P over dt equals 0.08 big P open 1 minus big P over 1000 close. A direction field for this equation is shown in figure 1. We show only the first quadrant because negative populations aren't meaningful, and we are interested only in what happens after t equals 0. Figure 1, direction field for the logistic equation in example 1. The logistic equation is autonomous. Open d big P over dt depends only on big P, not on t. Close. So the slopes are the same along any horizontal line. As expected, the slopes are positive for big P greater than 0 but less than 1000, and negative for big P greater than 1000. The slopes are small when big P is close to 0 or 1000. The carrying capacity. Notice that the solutions move away from the equilibrium solutions big P equals 0 and move toward the equilibrium solution big P equals 1000. In figure 2, we use the direction field to sketch solution curves with initial populations big P of 0 equals 100, big P of 0 equals 400, big P of 0 equals 1300. Notice that solution curves that start below big P equals 1000 are increasing, and those that start above big P equals 1000 are decreasing. The slopes are greatest when big P is approximately 500, and therefore the solution curves that start below big P equals 1000 have inflection points when big P is approximately 500. In fact, we can prove that all solution curves that start below big P equals 500 have an inflection point when big P is exactly 500. See exercise 13. See figure 2, solution curves for the logistic equation in example 1. The logistic equation, equation 4, is separable, and so we can solve it explicitly by using the method of section 9.3. Since d big P over dt equals K big P open 1 minus big P over M closed, we have theorem 5 or equation 5. The integral of d big P over big P open 1 minus big P over M close equals the integral K dt. To evaluate the integral on the left side, we write 1 over big P open 1 minus P over M close equals big M. These are all big letters, restarting that line. To evaluate the integral on the left side, we write 1 over big P open 1 minus big P over big M close equals big M over big P open big M minus big P close. Using partial fractions, see section 7.4. We get to big M over big P over big M minus big P close equals 1 over big P plus 1 over big M minus big P. This enables us to rewrite equation 5, the integral open 1 over big P plus 1 over big M minus big P close d big P equals the integral of K dt. The natural log of the absolute value of P minus the natural log of the absolute value of big M minus big P equals KT plus C plus big C. The natural log of big M minus big P the natural log of the absolute value of big M minus big P over big P equals negative KT minus big C. Absolute value of big M minus big P over big P equals e to the power negative KT minus big C equals e to the power negative C times e to the power negative KT. Equation 6, big M minus big P over big P equals big A times e to the power negative KT, where big A equals plus or minus e to the power negative big C. Solving equation 6 for big P, we get big M over big P minus 1 equals big A times big E to the power negative KT approaches big P over big M equals 1 over 1 plus big A times e to the power negative KT. So big P equals big M over 1 plus big A times e to the power negative KT. So we find the value of big A by putting t equals 0 in equation 6. If t equals 0, then big P equals big P sub naught, the initial population. So big M minus big P over, big M minus big P sub naught over P sub naught equals big A times e to the power 0 equals big A. Thus, the solution to the logistic equation is definition 7. Big P of t equals big M over 1 plus big A times e to the power negative KT, where big A equals big M minus big P sub naught over big P sub naught. Using the expression for big P of t in equation 7, we see that the limit as t approaches infinity of big P of t equals big M, which is to be expected.